Hi friends, today our topic on board why we are using 4 to 20 milliamps instead of 0 to 20 milliamps or some other value. The system why we required, suppose some physical system, example main engine temperature, boiler pressure, whatever we need to measure, it is measured by the sensor. After the sensor, it is convert the analog signal into electrical signal. Through the transmitter, the output proportional value sent to the PLC or DCS or DPU as like 4 to 20 milliamps. So why it is not start from 0? We can send signal to 0 also. The main thing is 4 to 20 milliamps, meaning is the analog least value is 4 milliamps, the most value is 20 milliamps. The in between value will be converted between the 4 to 20. So in this case we can make it 4 as 0 also, but we are not making. So we'll look into that. The first one mostly all the digital signal is like voltage signal only, but we are not transferring as a voltage signal, we are transferring as a current signal because of the line the wire have the resistance, due to the resistance voltage drop will occur. Second one, voltage is subject to electromagnetic induction, so due to this the noise will happen, but the currents are not subject to that one. The main important, if I take 0 milliamps instead of 4 milliamps, what happened? Suppose this 4 to 20 milliamps indicated that the range what we are going to measure from the lower value to higher value. For example, in boiler 0 to 10 bar, 0 bar will represent the 4 milliamps and 10 bar represent the 20 milliamps. In this case, if I take the 0 milliamps, 0 to 20, the 0 bar will represent the 0 milliamps. That's no problem. But the problem is, if line have some problem, if it is open circuit, we cannot find out the fault finding. So to find out the fault finding, we are not using the 0 as a basic value, lower range value, we are making above 0. But why we are using 4? We can use 1 to 3 also. The main reason for that, all the electronic devices what we are using, silicon control rectifier, SAR, so and so, it need to work at stable condition at least 3 milliamps. Above 3 milliamps only it will work perfectly. That's why we are using more than 3, not 0. So convert it to 4 to 20, and 4 to 20 the conversion rate of 0 to 100% is very easy. Okay, we will see how we can calibrate this by using of this. What is the formula? Example, if I have the chart, one side the temperature range, other side is a 4 to 20 milliamps. For any signal variation we are measuring from 4 to 20, the slope will like tangent. It's like in mathematical we studied about it. It's not the parabolic, it's a straight line. So the 4 to 20 milliamps, if we plot like this, we'll get the graph value equal to y equal to mx plus b. So what is that? What I'm trying to say, when you are measuring, electrical officer measuring some value in between 4 to 20, if you are getting some milliamps, then how we know that milliamp is exactly what the pressure showing there? So both are equal or not, or whether we require to change the sensor or we need to calibrate, we can find out so many things. So in that purpose, we will see the formula, and with the formula usage we will do some practical solution also. In this formula, y equal to mx plus b, y is the output signal, means how much the milliamps what we are measuring. X is the variable in percentage. The variable means the process value, the pressure, how much pressure is there, that we are converted in the percentage value. And m is the span. In 4 to 20 milliamps, span value is 16 milliamps, because 20 minus 4 16. And b is the lower range value. Yes, of course here lower range value, offset value is 4 milliamps. Suppose if you are using 0 system, 0, 2 means 2. So here the 4 is the lower range value. So output signal equal to span of percentage of variable plus LRA. With the use of this formula, we will see some practical solution, and by the guide in onboard, suppose if you are measuring something, you can come to know that hydraulic system or temperature range, RDT or thermocouple, it is showing the correct value or not. Okay, we will move to the problem. Example, if I have one system, like we take the boiler. Boiler pressure gauge range is 0 to 10 bar. Now the pressure state is 5 bar. This 5 bar from the sensor, it is convert through the transistor convert to some milliamps. That is showing 12 milliamps. So in this formula, how it happen? We will see y equal to mx plus b. The m is the 16 span value. 5 bar means 50%. So 50% divided by 100 of percentage plus 4. So output is equal to 12 milliamps. In the 12 milliamps showing means it must be 5 bar. So if there is any difference, what we find out according to the formula or what is really showing, that means there is some error. We need to take further action. Okay, my friends, thank you for watching my video.